Okay, so let's continue on this problem. We have solved the first part that says that front tires don't leave the ground. The next part says that slip of the tires doesn't happen. So part 2. So we will assume that is tires are about to slip. They don't slip, but they are on the verge of slipping. So in that case, they will have the static friction coefficient that we have in B will be mu and f of f will be mu s into nb. That will be the equation that we are going to use. Okay, so I will just put the equations back here with just the new value of f and then try to find the unknowns. So let's start from the first equation. F of f is magx, and instead of that one we will just say that f of f is mu s nb, and then the second equation will be that na plus nb minus w is 0, and then here instead of nb, okay, so no, this one is okay. The last one is that negative n of a times 1.82 plus n of b times 0.38 minus f of f times 0.55, that's equal to 0. And then from here f of f will be just mu s times n of b. Okay, and then now we can check the number of unknowns. So we don't know the n of b, the acceleration, and then n of a. Okay, so now we have mu s, which is 0.8. It is given in the problem statement. And then, so with this in mind, we will just use the equations that we have. So the first is that we will write these whole equations as this one is na plus nb will be equal to w, and then w is 9564, and then negative na times 1.82 plus the nb times 0.38 minus 0.8 times 0.55, that is 0.38 minus 0.8 times 0.55, and that is equal to 0. Okay, and then let's do that calculation. 0.38 minus 0.8, let's do the opposite. 0.8 times 0.55 minus 0.38, that is negative 0.06. So again, I will just write it. Na plus nb is equal to 9564 negative na times 1.82 minus 0.06 nb, that's equal to 0. Okay, and then we can solve them as we will multiply the first equation by 1.82 and then add this together. Okay, that is the procedure that we will follow. So 1.82 n of a plus 1.82 n of b, that will be equal to 9564 times 1.82, that is 17406. 17406. Then we have 1.82 n of a minus 0.06 n of b, that is equal to 0. And then if you sum, you will have 1.76 n of b 1706. From here n of b will be 17406 divided by 1.76, that is 9889. 9890. Okay, that's n of b. And then we know that n of a plus n of b is 9564. So I will just go back here. N of a plus n of b is 9564. And from here, n of a will be negative 980 plus 9564. And that will be, so 9890 minus 9564. That is 326, but negative Newton. Okay, so what it means is that normal force is less than 0, meaning the tires don't have left the ground. Okay, so they don't touch. This is for the front tires. That means that the μs value is not enough. Okay, you have to play with the μs value, and then you have to find the normal force that's enough to keep the tires in place, and normal force is greater than 0. Okay, so you can continue even, and you can find the acceleration for this one. So that's also a very easy task since we know the NB. So let's finish the calculations. Then mu s, the first equation, NB will be equal to m into AGX, and this one is 0.8. NB is 9890, and then m is 975, and then from here AGX will be 9890 times 0.8 divided by 975, that's 8 meters per second squared. This is the acceleration for this case, but as I said, this is not enough for the front tires to be able to touch the ground.